Finding the zeros of a quadratic. A quadratic equation is of the form y equals ax squared plus bx plus c, where a, b, and c are constants or real numbers. Before we talk about how to find the zeros, let's do a brief introduction about why we might want to find the zeros. And there are many reasons, but I'll give you a couple here. Some of them are outside the scope of the course, but it doesn't hurt to think about them. So, when you get to calculus, or if you decide to take that, we find that a function has either a maximum point or a minimum point, generally speaking, when the slope of the graph equals 0. For example, in engineering, you might want to maximize fuel efficiency. If you're designing a car or an airplane or something along those lines. Or you might want to minimize something. Like you might want to minimize, say, the wind drag, which of course will help with your fuel efficiency. But these are just two examples of many things. We can maximize or minimize things when the slope of a graph equals 0. And we can even do this in higher dimensions, but I will not get into that in this video. Another reason to find zeros comes from business. So let's define R of x to equal our revenue, how much money we're making in our company. And we'll define E of x to be our expenses. One thing we might want to do is find what's called the break-even point. Based on my expenses, how much revenue do I need to bring in? And that is, the break-even point is when our revenue equals the expenses. Now, what does this have to do with finding zeros? Well, very often, instead of finding something like this, we can rewrite the equation in the following manner. If we subtract E of x from both sides, we see that an alternate way of finding the break-even point is when R of x, our revenue, minus E of x, our expenses, equals 0. So just a couple reasons to kind of motivate why we might want to find zeros of a quadratic or later on a polynomial. So let's go back to our quadratic. We said a quadratic is of the form y equals ax squared plus bx plus c. And we know this equals 0 always when we do something called the quadratic formula. This and many things in the next few videos I expect will be second nature to you, or at least you have seen these things before. So the quadratic formula says my quadratic equals 0 when x is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this will always work if we have a quadratic. We can always find the zeros this way. We don't always want to. When we're finding zeros, generally speaking, we want to find maybe the simplest or the quickest way to find things. Even if there's a way that works all the time, and our way, the simpler way, doesn't work all the time. We at least want to start with a simpler method. And the simpler method we're going to start with is factoring. A note, this video is not a tutorial on how to factor. I expect that you have seen this before and that the video is here just to remind you how to factor and to do some problems with it. Suppose we have the function f of x equals x plus 2 times x minus 3. So I already have it factored for us. And we want to find where our function equals 0. Well, my claim is that we could set either of these factors, either x plus 2 equal to 0, or the other factor, x minus 3 equal to 0, which will give us either x equals negative 2 or x equals positive 3 when we solve. So why does this work? Well, when x is negative 2, we get negative 2 plus 2 times negative 2 minus 3, which equals what? Well, it equals 0 times something. This something doesn't matter, does it? Because any time we multiply by 0, the entire thing equals 0. We could do the same thing for an x equals 3. I won't do it here. You can plug it in if you'd like to. But what if we had something like this? X plus 2 times x minus 3 equals 1. Could I do a similar thing here where I say either x plus 2 equals 1 or x minus 3 equals 1? And I'll solve this back one here. This will give us x equals 4. So when x equals 4, I get that this second factor is 1. But if I plug in x equals 4 into my first factor, I get 6. Does 6 times 1 equal 1? Well, of course not. So factoring works by finding zeros if and only if we're trying to find whether a function equals 0. It doesn't work for any other number. I mean, maybe one time it could, but in general, it doesn't work when we have quadratics. So we're going to factor some problems. And I can certainly talk about some of the things I look for when I factor, which may or may not be different than something that you have been taught. If you have a different way that you like better, of course, feel free to do that. But let's factor this equation to find the zeros. One thing I usually do when I'm factoring is I try to see if every single term has a common factor in it. In this case, everything is a multiple of 2. So I like to start just with a quick search, if you would, by seeing if I can factor out something that every term has in common. And then I can factor what's left over. It's just a little bit easier when we have 1x squared instead of 2x squared or anything else. So now let's factor. A couple of things I look for. I know I have x squared up front, so I multiply to get x squared, give me x times x. I also multiply to get 3, actually in this case negative 3, but I'll put 3 and 1 here. And when I look at this back sign, this negative sign here, I multiply, I know one of the terms has to be positive and one of the terms has to be negative. So it's either plus 1 and minus 3 or minus 1 and plus 3. Well, how do I know which it is? Now I look at this middle term. And I know that I need to add to this middle term. So the outer terms we multiply to, and this middle term we add to. And we need to add to negative 2. Now, negative 1 plus 3 does not equal negative 2. But 1 minus 3 does equal negative 2. And so I have the correct factorization here. And then either 2 equals 0, of course that doesn't equal 0, I don't really need that at this point. Or I could say x plus 1 equals 0, or x minus 3 equals 0, giving us the solutions x equals negative 1 and x equals 3. Let's do a few more examples, just try to run through these sort of quickly. Let's look at x squared plus 6x plus 8. We want to find the zeros. Once again, we multiply to the x squared, so we're going to have x times x. We're going to multiply to positive 8, so I could have either, say, 1 times 8 or 2 times 4. Generally speaking, we use integers. It doesn't have to be, but usually we do integers. I know I multiply to positive 8, so it's either negative times negative or positive times positive. Since I add to a positive, I can't do negative plus a negative to get a positive, so it must be positive times positive. And I know it must add to 6. That is, my factors must add to 6. If I put 1 and 8 instead, then the 1 and 8, these factors would add to 9. I know that's not correct. So then we can solve. Either x plus 4 equals 0, or x plus 2 equals 0. And we get x equals negative 4 or x equals negative 2. All right, let's kick this up a notch. Let's look at one where we have 2x squared minus 7x plus 3, where these terms, the x squared, the 7x, the 3, they don't have a common factor. So I can't factor out a 2. I mean, I guess I can. There are ways to do it with factoring out the 2, but I prefer not to. I prefer to just say I need to multiply to 2x squared, which means I'm going to have 2x and 1x up front. I'm going to multiply to positive 3, so it's either really negative 1 times negative 3 or positive 1 times positive 3. Since I need to add to a negative value, it must be the negative times negative. So I have a choice. It's either 2x minus 1 and x minus 3, or 2x minus 3 and x minus 1. Now I need to add, it's really a combination, multiplication, and addition, up to negative 7. So if you ever learn the FOIL method, the inner parts, the OI being the outer and the inner, these things need to add up to negative 7x. So I get negative 2x here, negative 3x here, which gives me negative 5x, which means this one is not correct. But if I do the outer and the inner on this one, notice that we get negative 6x minus 1x gives us negative 7x. So that is the correct factorization, giving us 2x minus 1 equals 0, or x minus 3 equals 0. Lots of x minus 3's in this video. Giving us x equals 1/2, or x equals 3. Let's go a step further. Really, the video on just kind of plain quadratics is done. I'm going to go into higher level polynomials and other things. But if you just want to learn about how to factor a quadratic, you can stop the video here. If you want to go a little bit further, just stay with me. Let's see if we can find the zeros of this. X cubed plus 5x squared minus 6x, which is a cubic function. Can we factor this? Well, certainly, if we take the advice of looking to see if every term has a common factor that we can pull out before we start anything, and notice that every single term has an x in it. So if I pull out an x from the first one, I have x squared. From the second one, we have plus 5x. From the last one, we have negative 6. And now we can factor our quadratic. Now I'm going to do this one kind of quickly, because I think we get the idea. I'm going to double check to make sure I have it. I multiply to -6, and I add to +6 minus 1. I add to plus 5x. And now that I have three different zeros, I have either x equals 0, or x minus 1 equals 0, or x plus 6 equals 0. So my zeros are 0, 1, and -6. Could we do this with a quartic, a fourth degree? Well, it depends. Let's look at one type of fourth degree. X to the fourth minus x cubed minus 12x squared equals 0. Does every single term have a common factor? And the answer is yes. Every term has an x squared in it, at least. So if I pull an x squared out of the first term, I still have an x squared. Out of the second term, I have a -x. Out of the last term, I have a -12. And then I can set this equal to 0. Notice that I have a quadratic here. That's what I really want when I'm factoring. And I get x squared times, let's factor this back part, multiply to negative, so 1 is negative, 1 is positive. I could do some like factors of 1 and 12, or 3 and 4, or 6 and 2, but they need to somehow add up to 1. And this is the only one that could add up to 1. In fact, they need to add up to -1. So that would be the correct factorization. So we get either x squared equals 0, x minus 4 equals 0, or x plus 3 equals 0. Giving us our solutions of 0, 4, and -3. How about a different type of quartic? Let's look at this one. So quartic to the fourth power, x to the fourth minus 10x squared plus 9 equals 0. Can we factor out a common term from all of them? That is, a common factor from all the terms. The answer is no, we can't. Certainly not in a way that helps us. But do you notice a structure? What if we wanted to solve the equation y squared minus 10y plus 9 equals 0? Could you do that? Hopefully you could. You could say something like y minus 1 times y minus 9 equals 0. Well, how does that help us do the problem we want? Now, I'm not saying you have to do this in a problem, but I just want to show you mathematically, what if we did a substitution where y is x squared? If y is x squared, does x to the fourth become y squared? And the answer is yes. What if I plug in y for x squared here? That works. And of course the last term works as well. So you don't have to do a substitution. You might want to. But I'm just showing you that there's an underlying structure with this type of quartic that we see in a regular quadratic. Meaning, instead of writing the original like this, we could write it like this. Where y is x squared, we say x squared minus 1 times x squared minus 9 equals 0. Now, can we factor these terms? The answer is yes, we can continue to factor. This is what we call the difference of squares, if you remember. Probably from Algebra 2 you would have seen something like this. And we can factor this quartic, this fourth degree, all the way down to the following, giving us the zeros, -1, 1, and then 3 and -3. Let's continue on. Again, these are kind of advanced problems. that you may or may not see. I like to throw in a couple for my students. Because once you understand the underlying algebraic structure, we can extend it to other things, like this. Is this a quadratic? Well, let's make one note. 2 to the 2x is the same as 2 to the x squared. We'll talk about properties of exponents later on. So I have something like this. I have 2 to the x squared minus 5 times 2 to the x plus 4 equals 0. So instead of my variable being x, you can think of our variable as being 2 to the x. So I could factor it like this. Instead of x times x up front, I have 2 to the x times 2 to the x up front. I got to multiply to positive 4 and then add to negative 5. So that will give me the correct factorization. And then we could say instead of x minus 1 equals 0, we could say 2 to the x minus 1 equals 0. And then 2 to the x minus 4 equals 0. That is 2 to the x equals 1. Or 2 to the x equals 4. And these, I chose so we could do these in our head, hopefully. Because now we have to go an extra step further and say, well, what does x equal? Well, the first one, x equals 0, because 2 to the 0 is 1. For the second one, x equals 2, because 2 squared equals 4. But we have the same underlying structure as we did before. How about something like this? Even if you don't know what the sine of x is, could you at least factor something like this? Do you see the underlying algebraic quadratic structure? So instead of x times x, we'll have sine x times sine x when we factor. Multiply to positive 3, add to positive 4. And then we can say sine of x equals negative 3, or sine of x equals negative 1. I don't expect you to be able to solve these. Unless you've taken trig, you know that's not possible. And for this one, again, if you've taken trig, you know that x is 3 pi over 2 or 270 degrees, depending, or other things like that. But if you don't know that, don't worry about it. Can you at least factor? How about this final one? Let's define g of x to be quantity x over 1 plus x all squared minus 9 times quantity x over 1 plus x plus 14. Can you factor this one? Do you see the quadratic structure? Hopefully you do. Then instead of multiplying x times x up front, we will have the following when we factor. Add to positive 14, multiply to positive 14, add to negative 9. And then we have two things we can solve. Either x over 1 plus x minus 2 equals 0, or x over 1 plus x minus 7 equals 0. So we could say x over 1 plus x equals 2. And I'll just continue with this one down here. I'm going to multiply both sides by 1 plus x over here. So we can say x equals 2 times 1 plus x. As such, I do need in parentheses over there. They're implied parentheses down here. I can say x equals 2 plus 2x, or negative x equals 2, or x equals negative 2. Similarly, we can say x over 1 plus x equals 7. Multiplying over, we get x equals 7 times 1 plus x. X equals 7 plus 7x. And then negative 6x equals 7, or x equals negative 7, 6.